So today I want to talk about mathematical systems. All right, so mathematical systems are used to model all kinds of things in the real world, but in particular, it is just a logical system in and of itself. And here are the basic building blocks of a mathematical system. The foundation consists of understood terms. So, what are understood terms? Well, suppose you read a sentence and there was a word that you didn't know, what would you do? Either Google it or go to a dictionary. The point is, look it up. And so you look it up, and in the description, there's a word you don't understand. What do? Look it up. And in that description, there's a word you don't understand. What do? Look it up. Well, that process has to change at some point, and it changes when you've hit a common language and all the words are understood. So it might be a little disconcerting, but at the very bottom, there has to be some language that we understand. Now, built on top of that are definitions. Definitions are descriptions for our audience for words they don't understand. And then on top of that is built a set of axioms. Now, what's an axiom? An axiom is an assumed truth. And it is the set of axioms that define our mathematical system. So every mathematical system has a set of axioms, and those axioms are assumed truths. They aren't proven, they're assumed. And depending on what axioms you take, you have a different mathematical system. The only thing that's important is that the axioms you take don't contradict one another. How do you find your axioms? Well, if you're trying to have a mathematical model for a particular real world thing, you look at that thing, figure out what its properties are, and you might incorporate those in your axioms. The other thing that's important to keep in mind is we try to keep our set of axioms down to a minimum. We never put an axiom in if I can prove it by the other axioms. All right, and then what's built on top of axioms? We have what's called lemmas. What's a lemma? Well, a lemma is a proven truth that we use to prove other truths. And if we use a result often, we'll call it a lemma, we'll pull it out, we'll write it, and we will refer to it at times. Okay, and then on top of lemmas are called theorems. What's a theorem? A theorem is a proven truth. It's a truth that we prove using everything that came before. Other theorems, lemmas, axioms, and definitions. And finally, what is a corollary? Or if you're British, corollary. A corollary is a direct result of a theorem. All right, so this is what makes up a mathematical system. The key to a mathematical system is an argument or a proof, and there's several ways you can make an argument or proof. One such way is called a direct proof, and a direct proof consists of two elements, a set of premises and a conclusion. Now, traditionally in a mathematical system, these premises are assumptions for our theorem. Okay, so you have a set of premises. We'll call those P1 through Pn. P for premises, get it? And then we have a conclusion Q, which I probably should call C, right? But I'm not consistent. So if I have a argument, a direct argument or a direct proof, I write it like this. Here are my premises, P1 through Pn. Here's my conclusion. And it can be read like this. If P1 through Pn, then Q. That's going to be my argument. Now, when is an argument valid? Arguments aren't true or false. They're not propositions. They're either valid or invalid. So an argument is valid if, given all the premises are true, the conclusion is necessarily true. Okay, so anytime you have an argument such that if all the premises are true, the conclusion is necessarily true, then that argument is called valid. Now, so the only time an argument is invalid is if you can find a case where all the premises are true, but the conclusion is false. If you cannot find a case where all the premises are true, but the conclusion is false, then the argument is valid. So if you think about it for a minute, to determine if an argument is valid, what you do is you run a truth table. And in that truth table, you're going to have a column for every one of the premises, and you're going to have a column for the conclusion. And the point being, you only look at those lines where all the premises are true, right? Because those are the only lines you're interested in. So you look at each line where all the premises are true, and then you check the conclusion. In each of those cases, the conclusion must be true. If it is, then we say you have a valid argument. All right, so let's look at least one example. Here's an argument. P implies Q, therefore Q. So your premises are P, whatever premise that might be, and P implies Q, whatever premise that might be. And then the conclusion is Q again. This is written symbolically, and you can pick your own choices of P and Q. So let's run a truth table on it, and let's see if this argument is valid. All right, so I have two conditionals that are independent of one another. I have P and I have Q. And now I have to have all my premises, so P implies Q, that's a premise. Another premise is P, and the conclusion is Q, so these are the only three columns I need. Remember, if I have a truth table, it's going to be what? True, 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 false, false, true, false, false. Those are all the possibilities. Let me clean this thing up a little bit. And if you remember, the conditional statement is going to be what? True, false, true, true. And now what's the point? The point is I look at only those lines where all the premises are true. Now, what are my premises? P and P implies Q. All right, so I look at P and P implies Q. Here, they're both true. And that's the only place. So if that's the only place, that's the only line I have to look at. And what do I mean by look at? I mean now I check the value of Q. Remember, anytime all the premises are true, the conclusion is necessarily true. All right, but what's the conclusion in this case? The conclusion is true. And what do I conclude? That this is a valid argument. Remember, arguments are not true or false, they are valid or invalid. And I'm going to stop there.